Okay, so what I'd like to do is a little demo of WireShark here for you guys so you can have some idea of what to do with it on your assignment that's coming up. The assumption is that you've already downloaded and installed WireShark. The assignment itself has the information on where to get WireShark, and the instructions on how to do any installation related to WireShark are on the WireShark website. So what I'd like to show you is basically how it all works. This is what WireShark is going to look like when you start it up for the first time. Notice that on the left-hand side, under the capture area, we've got the option to choose which interface we want to listen to. If your computer has multiple network cards, notice that the list that's here doesn't have any obvious mechanism to know which one is actually connected to the network. So if you want to see what's connected to the network, click on Interface List. That actually pops up and you can see the packets that exist on each network interface. And in my computer, I've got 2 network cards, and only one of those network cards is physically plugged in, so you can see that's the one with the packets. And also, if you happen to know the brand of network cards that were in your system, that can make a difference as well. So local area connection 2 is going to be the one on my computer. On your computer, it's likely local area connection, or if you're on a laptop, you can be doing it through wireless as well. So I've selected local area connection 2, and you can see it just highlights it here. Doing it in either place would have been the same. And in terms of starting, all we need to do is click Start. And it is going to capture all the information it sees on my network. So the frames are adjusted a little odd here. So you can actually see it's capturing a whole bunch of information. You can see my Nintendo Wii doing a whole bunch of activity on the network there, and a whole bunch of things that I'm not doing yet. So our assignment is all about capturing packets for to view access to a web page, because I want you guys to see the basics of that. So that's what I'm going to do. I have a web browser open, but not visible. And what I'm going to do is I'm going to access a web page, and then we'll see what packets are available based on that. So I loaded up the packets on the web page, or I loaded up the web page, so we've got the packets captured. And then I'm closing my web browser just to make sure that everything shuts down nicely. And then I am going to stop the packet capture, because if we leave it up and running, it's just going to capture a whole bunch of junk we don't care about. Now, one way to find the packets that we're looking for is to just look through the list. We can look through every single packet that's here and figure out what we're looking for. However, as part of your assignment, if you don't want to look for all of that sort of stuff, notice that we've got things like the protocol here. You could sort based on that or something like that, but rather than sorting, I'm actually going to go to this expression option here to filter it. And the one I want is going to be DNS. Okay, so I'm just going to pick the whole thing here, and we'll see if we can go with that. And then I'm going to apply the filter. So this doesn't actually get rid of anything. And actually, before I even do this, I'm going to save my data, because I want you guys to send me your data, because I'm going to verify that it is what you think it is. So I am going to save this, and I will call it Byron MIS 3520, and done deal. Now I will apply my filter, and you can see that this filter gives me only the DNS related information, which is one of the things that we're looking for. So the website that I was going to was actually this csbstanford.edu. So you can, if we click on it, we can actually look at some of the details that exist inside it. So we talked about in class the different layers of the OSI model. Well, that's how this breaks things down. So we've got frame level, and notice that at the frame level, we can take a look at this, and it'll say what frame number it is, so basically just what it captured. So again, up over there it shows it's packet number 107. So we've got basic stuff there. Ethernet, so this is going to be, notice we've got a source MAC address and a destination MAC address. In my case, looks like it's labeling them both as D-Link, but that won't necessarily be the case for you. We've got our source and destination IP address also under Internet Protocol, and it breaks down again into more detailed stuff. And you can see that it is a UDP packet, and the source port coming from my computer is port 61062, and the destination it's going to is port 53, which is the standard DNS port. And if we break that up and expand and look at the DNS query, we can see stuff like, and expand it a little bit more. You can see it's doing a request for csbstanford.edu. So it's looking for an A record, so a host record. So if we go to the packet below that, which is the response, so you can see that it's coming back from the other computer. So in my setup here, my router 192.168.0.1 is also acting as a DNS proxy, so that's why the response is coming from 0.1. And if we take a look at this and look at the details of it, so everything stays expanded. And if we take a look in the response portion, we've got an answer now. And the answer is that CSB Stanford EDU is this IP address. So that's kind of cool. So we were able to break it down for DNS. If you wanted to see the web page related stuff, we should be able to do HTTP and see what that gives us. And so this is going to that Stanford one. So again, for me going out to that Stanford site, it's asking for that particular web page. So that's the web page that I wanted. So I'm just going to, if you want to look at the details of exactly what that request looks like, that's all the things it's looking for there. And you may or may not be interested, but notice that down below, we've got a hexadecimal version of your request as well as a ASCII version of your request. So you can literally read exactly what was inside the request. And it's sending things like what web browser, so that's this whole user agent, what web browser is making the request, because some websites will modify what they send back based on that. And so then a response from oh, sorry, I moved, yes. So we're looking at this one here. And then if we look at a response that came back from it, so we made the request, which was a GET, and then we get back code 200, which is okay. And you can actually see that the web pages starts to come down. So again, it's connection related information, and then the actual content of the web page is coming down. So all depends on how big the web page is and how much content there is as to how many packets are going to be associated with that. Sometimes it'll open up multiple connections, sometimes single connections. The other thing I wanted you to look at was TCP connections. And they are labeled for the TCP. And so specifically doing setups. So what do we have here? Scrolling up, scrolling up. I want to get the first part of the stuff for that website. And you can see there's a whole bunch of other background stuff going on. Okay, so this looks like the first packets doing a setup. So that makes sense. 107 and 108 were our DNS requests to get there, so it makes sense that 109 is the start of the TCP connection. So you can see my computer is communicating with that website, TCP, and it does a SYN packet. And then the Stanford server comes back and acknowledges that and does a SYN of its own, and then I acknowledge that back, and then we actually start requesting the web page. So that's our three-way handshake that starts off the TCP connection that we talked about in class. And then we also talked about the four-way teardown. And there might be a few of those, but we'll try and take a look kind of what's at the very end, because that should be more what we're looking for. 71, 171. Okay, so here's an example of the teardown process. So no, that's going to a different website, sorry. We want it to 171. Let's build it in the expression builder. So we will go with IP address, IPv4 equals. Then we want that 171 dot 65, 102.199, and apply that. And we'll erase all the junk I had in there before. That's better. And we'll apply that. Okay, and now if we look at the end of this, yeah, I might have cut some of this stuff off too early. It doesn't look like closed up properly. Because we've got our fin request and our fin ACK and then our final, yeah, okay. We're done. So the different connections might be a little bit mixed up. The web page that you guys will be accessing is a very simple web page, so it should very clearly have the 4 packet process for shutting that down. So I think you guys will be just fine.